Hello everybody, welcome into another lesson. So today we are going to talk about power to sum formulas for trig functions. Now, the first two you may recognize from yesterday's lesson when we talked about power reducing formulas for trig functions. And the first one is the cosine of x cosine of y. So that's equal to 1/2 of the quantity of the cosine of the quantity of x minus y plus the cosine of the quantity of x plus y. This is where the power reducing formula for cosine squared of x comes from, is this formula. Then if you have the sine of x times the sine of y, it equals 1/2 times the quantity of the cosine of x minus y minus the cosine of the quantity of x plus y. And this is where the power reducing formula for sine squared of x comes from. So these first two tie into yesterday's lesson. Now, these next two formulas and the previous two are also heavily used in calculus, especially in integration. If you have the sine of an angle times the cosine of an angle, so the sine of x times the cosine of y, that equals 1/2 of the sine of the quantity of x minus y plus the sine of the quantity of x plus y. And then if you have the cosine of x times the sine of y, that equals 1/2 times the quantity of the sine of x minus y minus the sine of x plus y. So all those are some product to sum formulas. So let's go ahead and do some examples. Hold on one second. Come here, buddy. Come here. Come here. Come on. Come on. Come down. There you go. Good boy. Sorry, I had to get my dog out of the window. He would have been barking the entire lesson, which he sees something, he'll start barking. Okay. So let's go ahead and do this here. Let's say I have 6 times the sine of pi over 3 times the cosine of pi over 3. Well, yeah, we can go ahead and just input the values. That is certainly true, but I want to show you how the product of sum formulas work. So this will be 6 times the quantity. So the product of sum formula for sine cosine is 1/2 times the quantity of the sine of pi over 3 minus pi over 3. And then since it's sine cosine, this would be plus the sine of the quantity of pi over 3 plus pi over 3. Alright, so this would simplify into 6 times the quantity of 1/2 times the quantity of the sine of 0 plus the sine of 2 pi over 3, which now we can just take these values. So this would be 6 times the quantity of 1/2 of, well, sine of 0 is just 0, but the sine of 2 pi over 3, that's the square root of 3 over 2. So 6 times 1/2 times the square root of 3 over 2, so this would end up being 6 times the square root of 3 over 4, which your final answer should be 3 times the square root of 3 over 2. So you should end up getting, for 6 sine of pi over 3 cosine of pi over 3, your final answer should be 3 times the square root of 3 over 2. Alright. Now, what if we did 4 times the sine of pi over 3 times the cosine of 5 pi over 6? So we got 2 different angles completely. Well, let's apply our sine and cosine formula. So this would be 4 times the quantity of 1/2 of the sine of pi over 3 minus 5 pi over 6 plus the sine of pi over 3 plus 5 pi over 6. So this would simplify further into 4 times 1/2 times the sine of, now what is pi over 3 minus 5 pi over 6? Well, pi over 3 is the same as 2 pi over 6, so this would end up becoming the sine of negative pi over 2 plus the sine of, now pi over 3 again is 2 pi over 6, so 2 pi over 6 plus 5 pi over 6, that's 7 pi over 6. So let's simplify this further. This would become 4 times the quantity of 1/2 of, what is the sine of negative pi over 2? That's negative 1 plus the sine of 7 pi over 6, so it's in the third quadrant. That would end up being actually negative 1/2. So this would be minus 1/2, which would simplify into 4 times the quantity of 1/2 times negative 3/2, which should end up giving you 4 times negative 3/4, or simply negative 3. Which makes sense because the cosine of 5 pi over 6 would be negative square root of 3 over 2. The sine of pi over 3 is the square root of 3 over 2, so yes, you should end up getting negative 3. This is just a longer way of doing it, but this proves to you that the product of sum formulas do in fact work. I got some more. Alright, we have the sine of 5 theta times the cosine of 3 theta. So this is a perfect example, especially if you're trying to integrate something like this in calculus. The sine of 5 theta times the cosine of 3 theta. So let's do our product of sum formula. This would be 1/2, and then since it's sine times cosine, so 1/2 times the quantity of the sine of 5 theta minus 3 theta plus the sine of 5 theta plus 3 theta which should simplify for your final answer into 1/2 times the quantity of the sine of 2 theta plus the sine of 8 theta. And that would be the best you could get. And this would turn this into a form you could integrate with. So you would have half of the sine of 2 theta plus sine of 8 theta as your final answer. All right. let's see, so we have 5 times the sine of 3 alpha times, is that also a sine? Yep. Times the sine of 4 alpha. So we have 5 times the sine of 3 alpha times the sine of 4 alpha. So we're going to apply, again, the product of sum rule, but this time it's for the quantity of 2 sines. Now, I might suggest something here, though. If you don't want to deal with an extra negative sign, I'm going to highly suggest that what you do, especially since they're the same function, you would switch this around to have the sine of 4 alpha first, then the sine of 3 alpha. If they're the same function, put the greater of the two first. So this can be rewritten as 5 times the sine of the quantity of 4 alpha times the sine of 3 alpha. That would probably make more sense. Now we can apply the product of sum rule for the sine function. So this would be 5 times the quantity of 1/2. Now a sine times a sine, 1/2 of the cosine of 4 alpha minus 3 alpha minus the cosine of 4 alpha plus 3 alpha, which would end up simplifying into 5/2 times the cosine of alpha minus 5/2 times the cosine of 7 alpha. So, especially in calculus and integration, this is hard to integrate directly, but the product of sum formula gives you something you can work with to integrate. So you should get 5/2 times the cosine of alpha minus 5/2 times the cosine of 7 alpha for your final answer. All right. So we have 10 times the cosine of 75 degrees times the cosine of 15 degrees. Since these are both positive angles, we should get a positive result, right? A positive times a positive is a positive. So let's go ahead and use the product of sum formulas for the cosine function. So this would be 10 times the quantity of 1/2 times the quantity of the cosine of 75 degrees minus 15 degrees plus the cosine of 75 degrees plus 15 degrees. Alright, so this would be 10 times the quantity of 1/2 times the quantity of cosine of 75 minus 15, that's the cosine of 60 degrees, plus the cosine of 75 plus 15, well, that's the cosine of 90 degrees. Alright, so now we got 10 times the quantity of 1/2 of, what's the cosine of 60? That's 1/2, so you would have 1/2 times 1/2, and cosine of 90 is 0. So you would end up having 10 times 1/2 times 1/2, which would end up giving you 10/4, or otherwise 5/2. So the answer you should get for this would be 5/2. Two, three, four, five, six. I have 7 more. Okay. So let's see, we have 6 times the sine of 45 degrees times the cosine of 15 degrees. So we have 6 times the sine of 45 degrees times the cosine of 15 degrees. Okay, well, let's use the product of sum formula for sine times cosine. So that would equal 6 times the quantity of 1/2 times the quantity of the sine of 45 degrees minus 15 degrees plus the sine of 45 degrees plus 15 degrees. So this is going to get to be fun. This would turn into 6 times the quantity of 1/2 times the sine of 30 degrees plus the sine of 60 degrees so this would be 6 times the quantity of 1/2 times, now what is the sine of 30? Well, that's 1/2 plus the sine of 60, that's the square root of 3/2. So this would end up turning into 6 times the quantity of, if you distribute that 1/2, you should end up getting 1 plus the square root of 3/4. Which, when we go to simplify this for the final time, you should end up getting 3 times the quantity of 1 plus the square root of 3, all that, all over 2. So 6 times the sine of 45 degrees times the cosine of 15 degrees is 3 times 1 plus the square root of 3, all over 2. I should have 6 more, then we'll be done. Alright, so we have 5 times the cosine of -5 beta times the cosine of 3 beta. Well, I'm definitely going to suggest that since the 3 beta is greater than the -5 beta, let's switch those orders around. So you should end up having 5 times the cosine of 3 beta times the cosine of -5 beta. Which now we can use the cosine times cosine product of sum formula. So this would be 5 times the quantity of 1/2 times the quantity of the cosine of 3 beta minus -5 beta. So that would actually turn into plus 5 beta plus the cosine of 3 beta plus negative 5 beta. So this would end up being 3 beta minus 5 beta. So this would equal 5 times 1/2 of the cosine of 8 beta plus the cosine of negative 2 beta. Well, okay, so this would turn into, of course, 5/2 cosine of 8 beta. But here's something else. What's true for the cosine of a negative angle? The cosine's an even function, so this would be the same as the cosine of positive 2 beta. So this would actually be 5/2 cosine of 8 beta plus 5/2 times the cosine of positive 2 beta, since cosine's an even function. So you should end up getting 5/2 cosine of 8 beta plus 5/2 times the cosine of 2 beta. Alright, I do have 5 more. I have the cosine of 2 theta times the cosine of 4 theta. Well, again, since the 4 theta is greater than 2 theta, I would switch the order, make this cosine of 4 theta times the cosine of 2 theta. So now use the product of sum formula for the cosines. You should get 1/2 times the quantity of the cosine of 4 theta minus 2 theta plus the cosine of 4 theta plus 2 theta, which should end up giving you 1/2 of the cosine of 2 theta plus 1/2 of the cosine of 6 theta as your final answer when you convert this into a product sum formula. It should be 1/2 of the cosine of 2 theta plus 1/2 of the cosine of 6 theta. Should have 4 more. Four or 5 more. I'll have to look. Up 4 more, but these last 4 are a doozy. Let's say you have the sine of the quantity of x plus y times the sine of the quantity of x minus y. So you have the sine of the quantity of 2 angles, which are both a sum of angles. Well, we don't need to break out the sum formulas. We can just still use the product formulas. We can just use the product of sum formulas. We're not going to have to bust out the sum formulas. So, this is the product of 2 sines. Let's go ahead and use the product of sum formula for the sine times sine. So this would be 1/2 times the quantity of the sine, and I'm going to put another set of brackets, the sine of the quantity of x plus y. No, it's not the sine, it's the cosine, excuse me. The product of sum formula for the sine times sine is cosine of x plus y minus x minus y minus the cosine of the quantity of x plus y plus x minus y. Alright, so let's go to simplifying the brackets. You'll end up having 1/2 times the quantity of the cosine of, alright, So x plus y minus x minus y. So x's are gone. Y, that would be the cosine of 2y. Then you'd have minus the cosine of, see, x plus x is 2x, and then y minus y. That's gone. So this would be minus the cosine of 2x. So that should really be your final answer then. You should end up getting half of the quantity of the cosine of 2y minus the cosine of 2x as your final answer once you go ahead and simplify this. Three more. All right. Now we have the sine of x plus y times the cosine of x minus y. So we have a product of a sine and a cosine. This is going to work out a little bit differently. So let's go ahead here, apply the product of sum formula for sine times cosine. So this would be 1/2 of the quantity of the sine of the quantity of x plus y minus that x minus y, all that plus the sine of the quantity of x plus y plus x minus y. So let's simplify this a bit. So this would be 1/2 of the sine of x plus y minus x minus y would just turn into the sine of 2y plus the sine of, all right, x plus y plus x minus y would just equal the sine of 2x. So your final answer should simplify into 1/2 of the sine of 2y plus the sine of 2x. Two more problems, then we're done. So we have the cosine of theta minus pi, good one, times the sine of theta plus pi. So we haven't really done a cosine times sine product yet, and these don't occur very often, honestly. It's normally sine times cosine. The cosine times sine doesn't occur nearly as often. But nonetheless, the product of sum formula for cosine times sine, that's going to be 1/2 of the quantity of the sine of these two quantities subtracted. So that'd be the sine of theta minus pi. Then that would end up being minus that theta plus pi. Now this, all that would be minus the sine of theta minus pi plus theta plus pi. Okay, so then we end up getting 1/2 of the quantity of, all right, so we have the sine theta minus pi minus theta plus pi. This would just turn into negative pi minus pi, so this would be the sine of negative 2 pi minus the sine of, all right, so theta minus pi plus theta plus pi, the pi's are gone, you just get 2 theta. Well, sine of negative 2 pi, that's just 0. So what you should be left with literally is negative 1/2 of the sine of 2 theta. So this should simplify into negative 1/2 of the sine of 2 theta in the end. And I got just one more. We have the sine of the quantity of theta plus pi times the sine of the quantity of theta minus pi. Well, we have the product of two sines, so let's use the product of sum formula for the two sines. So this would be 1/2 times the quantity of the cosine of the quantity of theta plus pi minus that theta minus pi, all that then minus the cosine of the quantity of theta plus pi plus theta minus pi. Well, this should simplify further into 1/2 of the cosine of, okay, thetas are gone here, so you would just get positive 2 pi. So 1/2 of the cosine of 2 pi minus the cosine of, alright, so add these together, you'll get, the pi's are gone, you should end up getting 2 theta. So you should end up simplifying this into 1/2 of the quantity of the cosine of 2 pi minus the cosine of 2 theta. Well, what is the cosine of 2 pi? Well, that's just 1. So your final answer should be 1/2 of the quantity of 1 minus the cosine of 2 theta. So yes, this should turn into 1/2 of the quantity of 1 minus the cosine of 2 theta. So that's it for this lesson, and now we're done with the more theoretical and fundamental identities part of trig. The next lesson is going to start getting into applications of trig. We're going to get into solving triangles that aren't even right triangles. We'll be able to solve any triangles. We'll deal with vectors and even trigonometric forms of complex numbers, those type of things. So the very next lesson we're going to talk about the law of sines. So I hope everyone has a great day. Take care.